This is a demo of Simbeor Transmission Line Assistant, AI agent powered with Simbeor SDK. It can be used to synthesize and analyze transmission lines, microstrips, PCB mostly, strip, microstrip, single-headed differential. First question, I need 50 ohm strip line for the electric thickness 4 mil and decay 3. It is capable of planning and executing the steps and obviously reasoning. Let's proceed with this calculation. It asked me to confirm before doing this, which is in this context I asked it to do this. So this is the result. Next request will be a little bit more complicated. I would like to have a sweep of traces, trace width, 1 mil step, and put it in table format. Okay, send. So this, in this case, it will create a function call for parallel computations of multiple cross sections with Simbeor SFS field solver. So no formulas used here. Here are the results. So next is more complicated request. Okay, 3.2 and explain all assumptions. Okay. In this case, I need width and spacing for 85 ohm differential strip line with dielectric thickness 5 mil. This is from plane to trace surface. So right here it explains what it does. In this case, it assumed, because if I didn't explain it, what I need. So it's half on copper, frequency at which computation, loss tangent, symmetric strip line configuration, H to H coupled differential pair, H coupled differential pair. And processes, first it will come up with some width, then it will adjust it and find the spacing for 85 ohm. Okay, let's proceed. Yes, very fun. Multiple steps are needed and data transfer between the steps, obviously. So it's all handles through LLM calls to brain basically seems like this was issue finding the differential trace spacing for specified parameters. This is one of the cases that okay, didn't come up with answer. Let's just fix use 6 mil trace width and find spacing for the same problem. Okay. Okay, it found the spacing and was not succeeding with the strategy that it put together. So this is also one of the possibilities when you work with probabilistic LLM. So now let's make it more complicated to use more tools. 50 ohm strip line, 1 on copper, and on isola Ethereum 40 dielectric with dielectric heights, multiple heights, and then compute impedance attenuation and delay for all cross section and output without table. Let's do it. So right here it also need two steps, but they are more definite. So in first case, it probably what happened, it used it identify widths for single-ended, and then we're not able to adjust spacing because of yeah, the width has to be reduced a little bit, and okay. um, Assumptions. Again, in this case, it uses 1 ohms copper. ITER is the electric constant loss tangent. Strip line geometry. Let's proceed. Yes, sure, that's what I need. And steps. Step 1 synthesis. And step 2 is analysis. And we'll get the result in a moment. Mostly it's delayed latency of communication with LLM. So expect this, obviously. And that's what we have. 3 mil dielectric trace width is 2.1 mil, and for 5 mil it's 4 mil trace width and lower losses. So want to give it a try, you can download it, Simbeor T-Line assistant from Simbeor knowledge base. Thank you.